So the Miller-Urey experiment was an experiment to try to see if the conditions that were present during the early epoch of the Earth, the time when the Earth was still, the oceans were just forming and the Earth was still relatively new, if those conditions were conducive for the formation of organic molecules. Uh, the experiment wasn't directly trying to have abiogenesis happen, but they wanted to see if the conditions of the early Earth's atmosphere would have been conducive to the formation of these molecules at the very least. Uh, they weren't expecting any kind of life to form, but if it did, that would have been awesome. The setup basically had a sample that they believed was similar to Earth's early atmosphere. It turns out, with more study since this experiment was first done, that they were a little bit off on their composition, but they uh, they still proved that you could form these complex molecules without any kind of sophisticated setup, so that natural formation of molecules is possible. They basically had some salt water, some ocean water type stuff. Uh, of course, it wasn't from the ocean since real ocean water already has living things in it, but they recreated ocean water. They had an atmospheric sample where they took different compounds and put them in that they thought were similar to the atmosphere, and that's really where they kind of didn't have it quite right in the when the experiment was first done. We didn't exactly know what the early atmosphere was like. They're a little bit off, but subsequent experiments that were done with atmospheres that more closely align with what the early atmosphere in the Earth was got similar results. Basically, with a electric charge moving through these kind of compounds, you can create organic compounds of varying degrees of complexity. And we've even found compounds, organic compounds, in planetary nebula in space, in clouds of gas and dust from space. Uh, so you can make these compounds in lots of ways. They're not real hard. However, no experiment we've ever done has been able to recreate abiogenesis. So we've never been able to create life in a lab. Another way that we could get life here on Earth is we could have life start somewhere else. The idea of life spreading throughout a solar system or even from other solar systems is called panspermia. It just means that life could spread through space, either on accident or on purpose. But you still need a source for life. The thing that this complicates for us is that it means that the Earth might not actually be the original source of life. So when we look at the Earth and its early conditions and we try to figure out how life formed here, there is a possibility that that's not where life formed in the first place. So we could be at a dead end or looking at false leads on that line of reasoning. There is routine transfer of material between the inner planets. So we've found a number of asteroids that are actually pieces of Mars. And it's possible, but less likely, to also have transfer between Venus and Earth. Venus is a little bit tougher because it's got a thick atmosphere. So most debris would burn up in its atmosphere. And Venus's gravity is similar to Earth's, which are both significantly stronger than Mars's gravity. So it's tougher to get things between Earth and Venus, but still possible. Earth and Mars is much easier, and we have a number of asteroids that we've actually been able to trace back to Mars. So what happens is if you have an impact on one planet, like a comet or an asteroid hits that planet, some of the debris from that impact, it can be going fast enough to actually escape the planet it's on, and you can get natural exchange of material from one planet to another. The same type of process could transfer material